Put your hands together for these guys from Newt Studios. Thanks for being here. Really appreciate it. Good to see you guys. Now, just to keep you informed, Newt Studios does, biological animations and visualization. So I'm going to let the guys take you deep diving into the cellular biological world. And once again, let's hear some real Friday afternoon type of noise here on the West Coast for Alexey Kashpersky and Mike Moran from Newt Studios. Come on now! Pow! Hit me! All right, thank you.
Thanks so much, everybody. I'm Mike.
Alexey.
So happy to be here. Truly an honor to be here with everyone and for everyone that's tuning in. I'm really excited to share
around the world.
That's right, worldwide, Newt Studios. So we want to share a little bit about our process, and we're going to kick it off with our demo reel. Give you a taste of what we do at Newt Studios. So thank you for that, and we are here to, let's switch the display settings. We're going to talk about how we use ZBrush to visualize the biological wonders and marvels that are happening inside all of us right now. And so a quick background on what we do at Newt, and we really tell stories about how therapies and devices work inside the body and with the body. We're at our core, scientific storytellers. We're showing how these complex processes happen in a visually interesting and hopefully exciting way, depending on the audience. And ZBrush is really essential to, creating all these forms, anatomical forms, at all different scales with realism, accuracy, and hopefully at the end inspiring some kind of awe. So we visualize for all different audiences, and a lot of the companies we work with are in life sciences, biotech, biopharmaceutical, commercial. And some of you may be wondering what is medical animation, scientific animation. Some of you may be very familiar. I'll do a quick background on what this field is. And anyone remember the movie Inner Space, 1987? Yeah, so, or maybe The Fantastic Voyage, or maybe The Magic School Bus, all these things. Inner Space was really like my first introduction to medical animation, and the excitement of what could be happening inside the body. So if you're not familiar, you should watch this. Dennis Quaid gets miniaturized into this little pod. He gets shot into Martin Short's character. Hilarity ensues. Cool voyage through the body. So this is that submersible pod. And this is really how I envision our studio. We are these voyagers inside the body, showing it with beauty and accuracy. So traditionally, the field of medical animation is, medical illustration. And a lot of you are probably familiar, if you've been to the doctor's office, you've seen a chart on the wall. You probably had references, some anatomical atlases, especially if you're, sculpting anatomy. And the purpose of medical illustration is, for education and training for patients and doctors to learn, how the body works. And now it's moved beyond illustration, and we have the tools of 3D gaming, design,
and 2D and 3D animation to really communicate science in a whole different way. And still, at its core, telling science stories for patients, for doctors, and it's in the field of medical, legal, surgical simulation. The applications are always growing. It's a pretty fascinating field. One question I get asked a lot is, how did you find this field? And I have a picture of a red F up here because back, I have to go way back to my childhood. I was exploring the woods, love of nature, love being outside, and I was always fascinated by these, the creatures in the woods, looking at pond water under a microscope, finding crayfish, and that fascination then translated into my earlier inspiration, sketches like this. And I want to have Alexey, sculpt some of these guys at some point. So I don't know what it is, a microbiome, alien landscape, not sure. And then eventually, let's skip ahead to college. I was a biology major, minored in studio art, pre-med, not sure where I was going. And for those of you who are still students and wondering where you're going, it's okay not to know. But I just followed my interests and, took a photography class and went to the biolab at night, and I took weird photos of these lampreys and other specimens in jars. Then skip ahead, I did find a grad school program. There's a few master's programs in medical illustration animation, and I was in Chicago getting a master's in biomedical visualization, where we learned traditional techniques and emerging techniques, and that's where I picked up animation. My first job was at a company called Visual MD, met a lot of really talented people there, and animated, all kinds of really cool scientific animations, and this is using microscopy or emulating microscopy to show an immune response to a wound. So these are little macrophages being recruited to a wound. So I was really able to bridge my, passion for art and science and find a field that was a good fit for me. And worked in the field for many years and worked with a lot of talented people, and eventually found this guy, Alexey, and we decided to go on a journey together, form Newt, and make a little pod and go inside the body. So we show the body at all different scales. We can, be inside of a heart at the organ and tissue level. We can be inside of a vessel, looking at red blood cells and fibrinogen showing a clot. We can be down to the protein molecular level, looking at DNA and proteins and molecules. And I just want to tee up a quick overview of our creative process here at Newt and the steps we go through to create a visualization before Alexey really wows us with the 3D process. So, a client will come to us with a problem or question, and we are there to offer a solution in some way. How do we tell a story? So one of our clients wanted to visualize, the impact of their treatment on metabolic enzymes. And we need to distill it in, a visual, succinct way. And we chose, cellular powerhouse, mitochondria, to drive the story. So once we have that little piece of the story, we need to do our research and look at, gather as much data as we can. And, Google image search is your friend. Textbooks are your friend. Gather as much material as you can. I found this cool electron tomography of an actual scanned mitochondria, and it's cristae. So all this data then, helps feed how we're going to show something. So we get into the sketching phase and then sculpting phase, and this is where the real fun and magic begins. This is a still from Alexey's model of the mitochondria. And then at the end, we add our materials, lighting, environment, and hopefully have something that can instill some sense of wonder or awe, keep our audience interested in what the concept is.
Thank you, Mike.
Thanks, guys. Thank you.
Hello, my friends. My name is Alexey. I'm an artist and Newt Studios co-founder. We all here in this room have something in common, and it's love to ZBrush. So before I will go deep into 3D stuff, let me tell you my love story. I grew up in beautiful Ukrainian nature. All the time I felt a strong connection between nature, animals, plants, and the bug that was climbing the wall in the classroom was 10 times more important for me than mathematics, history, or other stuff. So my dream was to become an econologist, but when it came time to apply to university, I wasn't able to find anything like that around, and my second top choice was, not surprise, art and sculpture. And nature is the greatest artist of all times. It's perfect in all its shapes. It's just amazing in all its drawings, patterns. It's nature. And the time that I applied to university, I felt this connection between this topic of my love to biology and art. Somehow it's built this artistic vision in me. And the reason why I'm telling this, how many of you ever tried to work on traditional sculpture or learn traditional sculpture? Okay, you guys will understand very well what I'm going to tell, how our work on traditional sculpture usually starts. We have to build the frame, the skeleton of our future figure, right? And sometimes it's so time-consuming thing that it takes up to a quarter of all time work on sculpture to create things like this. This is me, by the way, creating the metal frame for future sculpture. And it's very complex work. So here's why I'm telling this. One day my friend, a digital artist, came up to me and said, have you heard this new program, ZBrush? You can create actual 3D models there and sculptures. I was like, what? That's interesting. Let's see. And I tried this program, was very impressed, and this artwork was born. It's 2007. And I was looking at it, and the feeling that I was missing something very important, some very important point was in my head, and I was keep looking at this work, and finally I understand, oh my God, these sculptures can fly in space without the frame. I don't need frames anymore. And for me, it was a true revelation that somehow you can build the same quality product, the same quality artistic object without such a huge preparation process. And immediately this artwork was born, then this one, and if you will take a look, you'll see that the main intention here is to break the rules of gravity, just to make things fly. And then this one, it's 2009, I think. And then this one. And that's my ZBrush love story. That's how I fell in love with it. But you'll ask, okay, but how is this connected to your presentation topic, the biological wonders? So one day I was working on my usual project stuff, and my wife told me, hey, have you seen this contest online that you have to create the spaceship? I said, you know what? You know how I don't like to create the hard surface things? I'm not a professional in it. I cannot do things like that. And she's like, what's the problem? Make it alive. Make it biological. Okay, that was new. So I created this spaceship, the biological flying creature, and applied to this contest. And I put this artwork to CG Society and other websites. And in a week after that, I got an email on my, I got an email which was like, hey man, I like your artworks, would you like to move to New York? For me, for a guy who is living in Ukraine, it was like a kind of miracle. It was hard to take seriously, but here we go. That's how I get in the field, actually. One more thing I want to show you is my first test task for this company that invited me. It's a corpse of the person, and I think it's a stress test that they asked me to execute. They provide me a ton of photos. This person, legs separately, all opened up, organs spread out, and 1,000 of those photos, and I had to create this beautiful model. And that's how I get in the medical illustration field. So next thing, I won this. This is an artwork called the HIV virus, and I won the international contest with this artwork. And somehow the most questions that I have from artists is regarding this one. I prepared the ZBrush file with the work in progress stages, and if we will have time after our presentation, I will get back to this one. But now I want to start from something fresh and new. and it will be how to create the neuron. It will look like this. And now let's go to ZBrush.
Any questions for us so far?
Anybody, don't hesitate. Come back from the other realm.
I think we will have a Q&A afterwards,
Want to do Q&A afterward?
but we can do some now.
Well, don't be shy, Think about how I feel. Maybe questions. It's not every day that you get to grab these things, So, oh, there's an arm in there. Hold on, in the red zone.
How
Is
do
that
you?
microphone? Hang on a second. Where's that box?
Here's the box.
Somebody throw the box. Hey, throw the box over here. Hang on just a second. Throw this box. It's amazing. The first time ever. The flying microphone hit the ZBrush sucker. Oh, third and long. Focus. Touchdown. Okay, where you at? Put your hand up again. Yeah. Beauty, go ahead. Talk into the box.
Hello.
Talk into it. It's the
Excellent.
box.
Cool. So when you're looking at all these fine structured,
Just hold the box.
okay, is this better? I think it's off. Is it on? Do you hear me? Okay, great. How do you balance the challenge to represent natural structures and ways to communicate, indicate what's going on in them abstractly?
Good question, man.
Yeah, it's a very good question, and I think it depends on the scene we're trying to depict. Especially if you're inside of a cell. Part of the beauty of what we do is there's no video that can get inside of a cell at this point, but we are advancing every year towards cool imaging of how it actually looks inside of a cell. But if you're inside of a cell and trying to show something like a mitochondria or DNA, it's going to be crowded and things moving rapidly and tons of Brownian motion and probably no color. So I think, we have to choose that balance of showing things with accurate form, with as much data that, we know from before, and using convention, the ways that things that had been drawn before, modeled before. But then I think part of the beauty of, especially at smaller scales, is we have that liberty to add more color and light the scene differently and take these, artistic liberties in a way where, we're not showing something that's inaccurate or not true, but adding a level of beauty there to keep it interesting. So it's always a balance. It's a great question.
Yeah, the deeper we go into the scale, the more artistic freedom we usually have to make. Okay.
Fine point. You ready to go? No more questions, right? No more questions?
Let's do more questions.
No more.
I don't know. I thought I saw an arm. No? Yes? Is that an arm? Don't do that, Kyle. Okay, take it away.
Okay.
Alexey, go ahead.
So let's start. My favorite thing in ZBrush is that sphere. That's how we starting our neuron modeling. And first thing we need to create, similar to traditional sculpture, is the framing.
Alexey,
Yeah,
Julie wants me to tell you that she was good friends with the Z-sphere once.
I know.
Yeah.
I know. Good friends. A
Yeah.
lot of time together.
Thanks, Julie.
And again, ZBrush is the kind of instrument that you can go a lot of ways and achieve the same result. So there is no rules that you have to follow. It's always the freedom to follow different paths on certain stages of work. If you feel that some stage can look or be done easier or better, feel free to do this there is just my personal pipeline. So now we are creating the frame. From the very beginning, it will look pretty regular, but our goal when we are working with organic modeling is to make as unregular as possible to give more interesting shapes. Sorry, my English, by the way. So not to go through the whole process of doing this routine, I prepared the stages, so I will switch between them to save some time. But the general idea of creating the frame for the neuron is something like this. You can also mention that I'm almost not using the hotkeys. That's because I had a trauma of my left shoulder and wasn't able to move normally my left hand, and that's why I learned to do everything with the right. And it's hard to learn back. Okay, so just continue the same way for this. This is axon, right? This is the long.
Yeah, so this is the axon.
So you guys got the idea what's going on here. Let me switch to my presets really fast.
Depending on what part of the brain you're in, the neurons will actually look different and might have different lengths to their axons or different shapes to their cell body.
Which one is this? How do you think?
This is probably from the cortex, would be my guess.
Okay, so our goal is to build
From Alexey's cortex.
Our goal is to create the structure like this, so we can start moving forward with the retopology and adding more details on it. So after this shape is ready, I'm doing the adaptive skin, so we can have the actual model, 3D model, not the Z sphere, not the Z spheres. So here's where we can start doing actual sculpting work. There is only 2 separations here of the branches. Of course, the real neuron has much more of them, much more branching, and if you want, you can go deeper in Z spheres, go just more branching all the way, but I don't recommend doing this, and I will come back to this later why. So once this form is ready, the next step is to smooth some edges, to give it some shape, to give it some volumes. It will be closer to organic form. So it will look not like neuron from Alexey's brain, but a regular neuron. Just trying to make it more organic looking, more beautiful. Generally using only the inflate brush and smooth brush to get those shapes in place. Sorry. Just giving more randomness. Hello? One. Giving more randomness to the shape. This is the neuron's body, and it's usually pretty big. It's a cell, actually. It's
Did you know that grapefruit juice is a psychotropic inhibitor?
what?
Do you want me to repeat that?
Yeah, I said, did you know that grapefruit juice is a psychotropic inhibitor?
I don't understand. Sorry.
Yeah, it just keeps these things from firing. I mean, you know, after New Year's Eve, you can maybe find me in the Trader Joe's aisle, sucking the jugs of grapefruit juice. I just wanted to throw that out there.
Okay. So on this point, we need to get something that will look like this. It's a shape that is pretty ready to be sculpted.
There's room up front. There's room up front. Please.
I just don't want to spend too much time on doing this right now, so this is where I start usually the sculpting process. And again, you can see that the branching is still not here, not here. There is no branching. It could be with more Z spheres added there, but no need of them. So from this point, I'm just going dividing and start looking for shapes, interesting shapes. When I'm doing organic forms like this, I'm trying to think. Well, usually I'm listening to audiobooks. And when I was preparing for the ZBrush summit and working on the neuron model, I was thinking about some roots of the ancient tree, the tree that have seen a lot of history on its way, those magic roots. And now we are just blocking. Again, it's a time-consuming process, and later a little bit I will jump to almost finished sculpt to make things faster, but just to show how the process goes. And as in traditional sculpture, main thing is to try to give the object, your model, a correct and interesting silhouette or silhouette. How's it correct?
Silhouette.
Silhouette, yeah. So same thing in ZBrush. Just try to find a beautiful, interesting silhouette.
And this is where we're finding that balance between full accuracy and beauty in a shape. And all these finer branches are called dendrites, and that's how the neurons communicate with each other, sending signals between the dendrites.
It looks like some ocean creature, right? On this point. So this is just a raw blocking process. And slowly you need to give more details to find their places, to find their positions. Yeah, because we are working actually on the cell body and how it look like in nature. It's a lipid layer that covered with how they call this little spheres.
Phospholipids. Yeah.
Phospholipids. So usually it's spherical shape covered with those little bubbles all around. So yeah, this is artistic.
Yeah, it's probably
yeah.
in nature, and the brain's probably more even and regular. There are some really beautiful visualizations of neurons in the brain. I believe one called the visible brain. If you YouTube that, they're able to strip down the brain layer, like strip away the fats from brains, leaving behind neurons, and so it's essentially a clear brain, and able to image that, and from that imaging, they can do some really cool visualizations inside and see all the different layers of the cortical structures, all the different neurons. So because of that imaging, you don't always see the form the way it is here, but you can get some really nice shapes. And all that, will feed into our references.
Okay, so this is pretty rough example, but our goal is to get somewhere like this, where it's more detailed. Here's where I considered the body of the cell finished on this stage. Yeah. Does anybody have questions for now about the process?
So when you have a new client and you don't know kind of exactly what they're looking for, you know what the brief is, but like stylistically, sometimes they want it more stylized, sometimes they want it more accurate. When you first present something to them, you kind of give them like a range of styles, something more like this to something maybe more reserved, and then kind of see what they want.
That's a good question. So the question is, a client comes to us with a creative brief, and they, want to see some style examples, and how do we choose between, more stylized versus more accurate, or I think it really depends on the client. We like to push for a little more stylized and exciting look, and I think a lot of times clients, they see a lot of that in our work and want that look, but sometimes they want to see that range, and I think it's a fun challenge to be able to dial up and dial back and present, something that's a little more, even more illustrative, generic. I don't know. I think it's Alexey. I don't know if you want to chime in
Yeah, sometimes it's, if we talk about the neuron, sometimes it can be even just smooth surface. Just smooth surface and receptors on the surface, and that's it. That's all client want. And sometimes client want, okay, give me hyper-realistic picture with a lot of details, and that's when I'm going this way.
And we always, need to think about, of course, the audience. What's the purpose of what we're creating, and what are we trying to achieve? Yes, we want to keep the client happy, but also hopefully they're thinking about, what is this going to be for?
Okay, so the next step is pretty interesting and unusual. Here's what I'm doing. I need to build the dendrites further so they are not splitting only one time here. I need to add additional splits. So I go a little bit lower topology and masking the shape. Actually, I can, 1 second, I'll hide everything. I'm masking the shape that will look like this. And it's a pretty unusual way of doing things, I know, but I'll explain why I'm doing this. And I'm doing extraction. Too much. So. Yes, something like that. I'm smoothing out this thing and start playing with the move brush. Quick remesh to make it more even. Oh my god, wrong thing, sorry. Okay. Clean topology. And now we will build the dendrites by moving them and making the beautiful branches that will grow all the way from our base mother model. It can be a pretty time-consuming process, but you will ask, okay, what's the reason for you doing this? So now I'm just duplicating this shape, moving it here, and continuing all the same thing. Make it look like it's growing here. So what's the point of doing the dendrites this way? If you'll take a look at this image here, yeah. If you'll take a closer look at the axon here, it consists of these stripes, like lines, that goes all the way through the body of the neuron. The same thing here. If you'll take a look at the dendrites, they consist like from different, they are not solid mesh, but like a wires in the, it just makes the shape look more interesting and more organic by doing those dendrites, the method that I'm showing right now. It gives more life to the model. So once this process is done, you have to have something that will look like, like this. That's after moving all those little parts. I know it's really time consuming, but it gives a really nice wood of organic looking tentacles. Next step is to give it more. Oh, by the way, it's another reason not to use the Z-sphere splitting more, because when you are on the stage of creating the topology for the body model somewhere on this stage, when you're creating just a base mesh, the topology that you will have on the tips here and the topology that you will have on the body of the cell, it will be pretty similar after applying the Z-remesher. And if you will have more branching and you will apply Z-remesher, it will just kill the topology on the very tips. So that's why I'm killing 2 rabbits with 1 bullet. I am having the same topology on the body, and I have ability to give more detailing, more life, more organic look to the very tips, the farthest parts of the neuron. So that's the reason why I'm not going further than this in the Z-sphere modeling. So okay, after this is done, I start, I'm usually moving a little bit to give more organic look and to split the branches just a bit, so they will look, and this is the wrong thing, yeah, like this. A little bit different, but a little bit more organic.
Can I ask you a question?
Sure.
There's a question coming in on the Twitter feed. Got a question coming in, and it's, use any scanner point cloud data for scans? Not for cells?
What kind of data?
Yeah, do you use any kind of scan data or point cloud data when you work with this type of thing?
That's, yeah, it's an awesome question. We don't in our pipeline right now. I think we have worked in the past with point cloud data. There are, at the cellular level, there's not necessarily point clouds that I'm aware of, but there's ways of taking imaging and creating something like point cloud data and then reworking from that. So I think at least as a reference, we have used data like that before.
Yeah. It's a very good point. 3D scans is a big thing, especially for the reference. For example, the corpse model that I showed in the beginning of the presentation, from those photos that were made in the morgue, I was able to create, the people who provided this task were able to create a simple, like a 3D mesh, and I used it as a base, as a frame to build the later 3D model. The same for cells, the same for other muscle tissues. If you need to be super accurate, usually you ask for the 3D scans. It helps a lot. But for the cell level, I don't think there is something so much accurate.
Yeah, it'd be more point clouds that then you have to work with.
If I'll have more time later, after I finish Neuron, I will talk more about the HAV, and I'll touch this point. Yeah.
Yeah. So there is a database called PDB. So scientists are able to crystallize proteins and then distill out the structure from that. So you can go to PDB or the PDB repository, search for a protein or an enzyme or something like DNA, and you'll get, the actual protein structured and the amino acids. There's a few different viewers. So if we're working at cellular and protein level, we use data from that as much as possible.
Okay, so on this point, I want to add more details to the surface, but not by sculpting the details on top, but with going a little bit slightly different way. I am doing remesh for the whole mesh. So I have the temporary representation of my neuron, but with the even topology. If you'll take a look here, we did a remesh and the topology is pretty the same on all the parts. Why I need this? I need this to make the beautiful and the equal mask through the whole body. So I just start masking the parts of the mesh where I want to extract the parts, and here is the mask that I prepared. It looks like this. It's a masked shape. It doesn't have to be super accurate. It just need to feel and repeat the overall shapes and forms of your model, and to pronounce them louder, even more louder than in your base sculpture of the body, of the neuron body. And then you just extract the mask. You know how to do this. It's here. We have this. Wait, that's too early. We have this shape that continues the form of the neuron. So now I'm removing the temporary mesh that we created and going back to the mesh that we built previously. Not this one. This one. Okay, as you can see, this new mesh that we created, those additional lines continue and follow the shape of the structures on the neuron by itself. And the next thing, I'm applying the noise modifier to this shape. It's here. I actually love it so much. It gives so much variety and life to the object. I love this modifier. And I'm getting something like this. Not necessarily this, but this is what I got for my variant. And it looks so much more interesting, right, than before. Adds a lot to the shape. And I can even do the second level of these details made by the same way to give these spaces, empty space and open spaces, and make the look like it's alive, it's branching, and it's breathing. That's my goal. So now when our, I would say, main work is done, we can go to the more detailed details. And I'm doing that by using the fiber mesh. I'm applying fiber mesh to the surface. And that's where our temporary mesh of the remesh of the neuron can be handy again, to apply the fiber mesh on top, to have all the structures covered equally. But yeah, we have so less time. Okay. We're applying fiber. As for the fiber mesh, I have the preset that I did for all my artworks, like a starting point that I'm using, and it looks like. Second. It looks like this. This preset I have saved, and I am starting from this point whenever I need the small details on the body. So I can adjust in the modifiers, playing with all the settings. until I will have something that will look like this. It's all possible to do with just playing with those settings. It's such a beautiful instrument that gives so much freedom to add the details. So this is the synapse. They have this shape where the end is a little bit thicker than the line, and that's how neurons are connected and talking to each other, right?
Yeah, these are the all boutons, maybe a little shorter depending on the neuron. But yeah, they speak to each other. There's a space called the synapse. So when they connect with another neuron.
Speaking of speaking to one another, how about some questions?
Go on.
Anybody got any questions out there? I'll throw you the old speaker box. Here you go, Mike Moran in the front row there. Here we go, bam. Speaking to the box, the Z box.
Am I speaking into?
Yeah, there you go. Now you hear yourself. There you go.
Hello.
Hello.
Z box.
Here, not to be confused with Mike Moran.
That's right. Well said, sir.
Awesome demonstration. Very complex. I can't believe you did it in an hour. It's amazing. Do you guys do a lot of this work for textbooks, or is a lot of it for patents or motion video? What's the primary job you guys do in this field?
Thank you. Mike, you will answer?
Sure, yeah, it's mostly, animation or stills for, online videos. So the clients are more like a pharmaceutical company or device company or a biotech company that, wants to show their product on their website or at a conference, or teach how, show how it works to patients or doctors. So that's generally the format. The field still exists where, there are textbooks or media like that. Alexey's worked on projects for print. So, each project's a little different, but generally, yeah, it's animation or stills for online animation.
And then after ZBrush, are we going to like Adobe After Effects or what?
After Effects.
Yeah. Okay.
3D
Cool.
Max, Cinema 4D, V-Ray, Redshift, no matter what, just making beautiful.
Very cool. Thank you.
So I will get back to this.
Nice
After
question. Throw me the box.
After we're done with the first level of fiber mesh, I'm usually adding another one level. Like here you can see these little small guys that you apply on top of the first fiber mesh. To give even more little details. And the
Man had a golf hole in the basement. He said, "Oh, never mind. I'll tell you later." You got another question here, NASA in the front row. Catch the box. What's your name for the record? My name's Chris. Chris, ladies and gentlemen. Is this thing on? Is this thing on? Hello, hello. Oh, no, I'm on. Are you on? Are we on? Let me see. Are you ready? Yeah, looks like we're on. Let's try that.
Okay.
You got to put something in there.
I saw in your animation that some of this stuff is kind of like wiggling around and animating. It kind of sounds like a nightmare to do it actually physically. All that was in compositing, or how much do you think about what you're going to be animating when you're modeling?
So thank you. After I'm done with the model, there is a process of optimizing the mesh and the neuron to be animated. As you said, it's sometimes a madness to animate things like this because it's millions of polygons, and you have to be very attentive and very thoughtful about the next step of production. It's a very good
Nice
question.
catch.
So sometimes it takes a lot to optimize the mesh in a correct way, correct polygons, but then you can actually optimize with noise. The neuron that you saw, there were 3 levels of noise overall, then the smaller one and the smallest on the tiniest little guys. And that's not the hand animation, but the light that you saw that going through the axon to the body and then to the dendrites, this thing was animated with hands.
Last question as the smoke starts to billow and fill the room.
Magic, what do I do?
You
Oh,
just
hi.
put the box
Hi.
near the face and let them have it.
My name's Rigel. I'm curious to know, this is more of a high-level question. When you're working with a client who has a really low fidelity, visualization, maybe it's like a new pathway that nobody's ever seen or something. Do you have a set creative process? Like, how do you have that conversation to figure out what you're going to do and what it's going to look like and what the final product? Do you have set stages that you follow every time? And you look like you're on fire, by the way.
I feel cool. So yeah, I mean, going from like a low fidelity reference, sometimes even like a client sketch or a physician sketch, that's part of the fun and part of the challenge sometimes. So, you know, everything we do has to go through a sketch and storyboard phase, even if it's going to be a still, to make sure we're capturing, you know, what they anticipate and making sure. So we can sketch probably better than most of our clients. Hopefully, that's why they come to us. So, and we don't want to jump right into 3D and get all detailed right away. So this saves our production time. Yeah. So generally, our process is, you know, sketch, storyboard, and in the storyboard, you know, include descriptions and, you know, this the action we anticipate, or this is, you know, the morphology that you want to see. So yeah, there's that back and forth depending on, you know, how lo-fi it is, and but it's fun too because you know, when it is something new like that, you know, they get really excited about seeing it come to life that in a way they haven't seen before, and that's you know, super fun for us.
Okay, that about wraps it up. Let's have a big ZBrush Summit Day 1 round of applause. Mike Moran and Alexey Kashpersky from Newt Studios.